Hello everybody, welcome back to part 14 of the Learning Everything We Can Learn from VisionOS Documentation. Here we're going to look at tracking pre-registered images in 3D space. We're going to place content based on the current position of a known image in a person's surroundings. Let's dig into the overview. Use ARKit support for tracking 2D images to place 3D content in a space. ARKit provides updates to the image's location as it moves relative to the person. If you supply one or more reference images, in your app asset catalog, people can use a real-world copy of that image to place virtual 3D content in your app. For example, if you design a pack of custom playing cards and provide those assets to people in the form of a real-world deck of playing cards, they can place unique content per card in an immersive experience. The following example tracks a set of images loaded from an app asset catalog. Here we have our ARKit session, and now we have our image info for the image tracking provider. Here we're looking at a reference image, and here are our playing card photos in this particular group of assets. Next, we're going to have it use our image tracking provider if it's supported. We're going to have the session run and update the anchors, which updates our image function. In this function, what we do here is we look at the anchor, take a look at the anchor ID. If it's not, if it's nil, we're gonna add it. Now we have an entity, and we generate a sphere that we're gonna place to this entity, right? And so the root entity, add child entity. If anchor is tracked, anchor id.transform, and we have a transform here. I would love to put this code into action and see it work. Here I have some sample code I've written for you. We have our image tracking provider created here. This will be ran in our session. However, to run it, we will need to make sure that image tracking provider is supported and that we have the required permissions. First things first, we find out that we can't get permissions for the image tracking provider. And you may notice that we have the world sensing for as an enum. Well, the reason why we have world sensing is because the world sensing authorization provides us with plane detection, scene reconstruction, and image tracking provider authorization. The thing is, there's only two types of enums. There's only hand tracking and world sensing. The one that we're using here is world sensing. And if we do a breakpoint here, we'll find out that we're not getting a request to get permissions. Let's try it, and let's go to this breakpoint. As you can see, world sensing is not determined, and we did not even get a chance to say, yes, let's authorize world sensing for this program. Another thing is that when we get straight to image tracking provider, what is going on here is that it's going to give us a no, image tracking provider is not supported. Let's check that out. And we don't actually know why. We don't know why that's happening. But with a implicit request for authorization rather than explicit request for authorization, we'll find out the reason. So how does this work is we move this task outside of this if statement. So let's block this off and let's push this into our do block. Let's run this, and you will see that when we push this button and run this task, what happens is that we find out that the AR image tracker provider is not supported for the simulator. So we can't go any further than what we're doing here now. This was a good article if we have the device, and we will be able to test our code. It will be great to create card games that has AR objects on them, and I think that'll be a very cool experience. However, we can't do that right now because we don't have the device. And so let's move on to our next piece of code in our next video, destination video. It's another piece of sample code, and I think we'll learn a lot from that piece of code in the Apple Vision Pro documentation. So please wait for the 15th video, and I'll see you in the next one. Thank you. Bye.